Hey there, Seahawks. It's Miss Adams, and in this video, we're going to work through some of the textbook problems on page 455. So, problem 13, it says baseball fans. In a poll taken in March of 2007, Gallup asked 1,006 national adults whether they were baseball fans. 36% said they were. A year previous, 37% of the similar sized samples had reported being baseball fans. Find the margin of error for the 2007 poll if we want 90% confidence in our estimate of the percent of national adults who are baseball fans. Part B, explain what the margin of error means. Part C, if we wanted to be 99% confident, would the margin of error be larger or smaller? Explain. Find the margin of error for 99% confidence. In general, if all other aspects of the situation remain the same, will smaller margin of error produce greater or less confidence in the interval? Do you think there is a change from 2006 to 2007 in the real proportion of national adults who are baseball fans? Explain. Okay, so in 2007, our N value was 1006 and p hat was 36%. Okay, that's sample proportion. Part A, they wanted us to find the margin of error. Okay, so margin of error is z star times the square root of p hat times 1 minus p hat over n. So z star would be 1.645 for 90%. The square root of 0.36 is our sample proportion. 1 minus that is 0.64 over n, which is 1,006, gives us 0.0249. So that's our margin of error. Okay, so it's basically our sample proportion plus or minus that margin of error. Okay, so part B, it says we are 90% confident that this sample's results is within 2.5% of the true proportion of people who like baseball. Part C was larger. Okay, so z star would be 2.576, not 1.645 if we bumped up the confidence. Okay, so if we increase that confidence level, our margin of error is going to get larger because we're going to multiply everything by a bigger number. Part D, they wanted us to find the margin of error at when our z star was 2.576. So multiply that, I get 0.039. Okay, so what happens is we become less confident. Okay, because before we had 2.5, now we have 3.9. And then F, no, our full interval for 95% confidence for 2007 would be between 0.335 to 0.385, which is still contains 37%. Okay, so that value from 2006 still falls within our interval. Okay, remember to get our interval, we take our sample proportion, which is 36%, plus or minus that margin of error value that we got. All right, number 15, contributions, please. The Paralyzed Veterans of America is a philanthropic organization that relies on contributions. They send free mailing labels and greeting cards to potential donors on their list and ask for a voluntary contribution. To test a new campaign, they recently sent letters to a random sample of 100,000 potential donors and received 4,781 donations. Part A, give a 95% confidence interval for the true proportion of their entire mailing list who may donate. And then Part B, a staff member thinks that the true rate is 5%. Given the confidence interval you found, do you find that the percentage is plausible? Okay, so my sample proportion is 4,781 out of 100,000. Which gives us 0.04781. and n, our sample size, is 100,000. I'm going to check the conditions. Has to be random. Well, that was stated. I have to have that success fail condition. That's where n times p has to be greater than or equal to 10, and n times 1 minus p has to be greater than or equal to 10. If I check that smaller one, I get 4,781, and so obviously the bigger one's going to be even bigger, so those check out. It has to meet that 10% condition, okay? So we can assume there are more than 1 million potential donors. So we can now say conditions met. This is going to let us use a normal model and perform a 1 proportion z interval. All right, so the work for that is p hat plus or minus z star times the square root of p hat times q hat, which is 1 minus p hat, over n. And I'm going to plug in everything I know. Well, p hat was 0.04781 plus or minus the z star for my confidence level is 1.96 times the square root of 0.04781. 1 minus that gives me 0.95219 all over 100,000. This gives me the interval from 0.04649 to 0.04913. Okay, and you can do this in your calculator, but you need to make sure that you're showing some sort of work, whether it's just the formula with the P's and Z's and Q's, or if it's with numbers plugged in, whichever you feel more comfortable with. If you think that you have a chance of maybe forgetting to put the hats on there, I would just stick with plugging it like with numbers plugged in. That way you don't have to risk it. All right, so then interpret this. We would say we are 95% confident that the true percent of potential donors who make donations after they get their mailing is between 4.649% and 4.913%. Okay, and then in part B, they were saying is 5% reasonable? Well, no, because we were already 95% confident of this interval, and our sample size was very large. So that makes us pretty sure of the interval that we got, and 5% falls out of that interval. Okay, so then part B would be no, and then you'd make sure you explain that that percentage is not within the interval, and you have reason to believe that is a pretty good interval at a 95% level with such a large sample size of 100,000. All right. The next couple ones, I'm just going to give you the answer. I'm not going to work it out step by step. So hold on. All right, here we go. Gambling. A city ballot includes a local initiative that would legalize gambling. The issue is hotly contested, and 2 groups decide to conduct polls to predict the outcome. The local newspaper finds that 53% of 1,200 randomly selected voters plan to vote yes, while a college statistics class finds that 54% of 450 randomly selected voters are in support. Both groups will create 95% confidence intervals. Without finding the confidence interval, explain which one will have a larger margin of error. And then part 2, find both confidence intervals. Part C, which group concludes that the outcome is too close to call and why. Okay, so for the newspaper, our sample proportion was 53% with a sample size of 1,200. For the stats class, our sample proportion was 54% with a sample size of 450. Okay, the stats class will have to have a larger margin of error because they have a smaller sample size. Okay. The newspaper, we're going to check our conditions. Okay, and then for the stats class, we're also going to check our conditions. So first, we're going to check that it is random. Okay, so SRS stands for simple random sample. It did state that it was random. Then we have to check that n times p hat is greater than or equal to 10, and n times q hat, which is 1 minus p hat, is greater than or equal to 10. Okay, this works out in both cases that it is greater than or equal to 10. My population has to be greater than 10 times n, that 10% condition. We can say that there are more than 12,000 students, and there are more than 4,500 students. Okay, so we can say conditions are met. We're going to use a normal model We put our mean and our standard deviation for that normal model, and then we can use a 1 proportion Z interval. On the next one, we also say conditions are met. There's our normal model with the mean and standard deviation, and we're going to use a 1 proportion Z interval. So for the newspaper, I'm going to just use my formula with the numbers plugged in. So it's our sample proportion plus or minus the Z star value. All right, and we were doing 95%, so 1.96 times the square root of p hat times q hat over n. So there's all my information. That gives us an interval of 0.50176 to 0.55824. And again, you could actually just plug this in your calculator. You go to stat, test, then do a 1 proportion Z interval, plug in all your information, it'll give it to you. Then just put the numbers in to show your work, okay? For the stats class, I'm going to do the exact same thing, except for using the different numbers. And that gives me an interval of 0.49395 to 5.8605. So the newspaper class is 95% confident that the true percent of people voting yes to legalize gambling will be between 50.176% and 55.824%. However, the stats class concludes they are 95% confident that the true percent of people voting yes to legalize gambling will be between 49.395% and 58.605%. So the stats class, because 50% is in the interval, it doesn't exceed 50% on both ends of the interval. It's possible that we're unsure, so it kind of doesn't give us a certain reading. We are unsure whether the local initiative will pass. Okay, it has to pass with receiving more than 50%. So it doesn't have everything over 50% like the newspaper does. All right, graduation. It is believed that as many as 25% of adults over 50 never graduated from high school. We wish to see if this percentage is the same among the 25 to 30 age group. How many of the younger age group must we survey in order to estimate the proportion of non-grads to within 6% with a 90% confidence? Part B. Suppose we want to cut the margin of error to 4%. What's the necessary sample size? What sample size would produce a margin of error of 3%? Okay, so we're going to find the sample size for 6%, 4%, and 3%. Okay, now this, we don't actually know the sample proportion for that 25 to 30 age group that it was asking about. Okay, I know the sample proportion for the other age group over 50, I think it was. So I would do like A, B, and C in this first half, where I'm going to use 50% for P hat and 50% for Q hat, just because that's going to give you a larger sample, so it's going to help you be a little bit more sure in your answer. If you use the 25% as your P, then your answers are as below. Okay, but if you don't know the sample proportion, the rule of thumb is to go with 50%, because that will give you the largest numbers, and that will help you be a little bit more accurate in the long run. Okay, so remember that our margin of error formula is Z star times the square root of P hat times Q hat over N. Okay, we want it to be equal to 6% in the first one. So I'm going to set it equal to 6%, and then I'm going to just use some algebra to solve for N. Okay, and then I'm going to set up the second one. I want it to be equal to 4%. Set it up the exact same way, except for the 6% is 4%. And same in part C, set it up as it's 3%. And then just do algebra to get N by itself. Okay, and then remember to undo the square root, you're going to square both sides. Okay, so I would start and I would divide by 1.645 on both sides. I would do 0.5 times 0.5 under the square root. I would get rid of the square root by squaring both sides. And then I would multiply by the reciprocal to get N by itself. All right, 30. Hiring. In preparing a report on the economy, we need to estimate the percentage of businesses that plan to hire additional employees in the next 60 days. A. How many randomly selected employees must we contact in order to create an estimate in which we are 98% confident with a margin of error of 5%. Okay, so 98% confidence means we're going to actually have to figure out that z-star value because that's not one of the ones that we typically use. So that's where we'd use inverse norm. And we'd do 0.98, mean of 0, standard deviation of 1. All right, suppose we want to reduce the margin of error to 3%, what sample size will suffice? And then why might it not be worth the effort to try to get an interval with a margin of error of only 1%? Okay. So for the first piece, we had to get that z-star for 98%, which came out to be 2.326, again, inverse norm. They wanted it at 5%, so I'm going to set up the same thing, 5% z-star times the square root of p hat times 1 minus p hat over n. They didn't give us any sample proportion, so we would use 0.5. I'm not sure why this is so blurry, but I'm sorry. And when we work this out algebraically, we get n equals 542. Then we're going to change it to 3%, and we get 1,503. And if we change it to 1%, I get 13,526. So it would not be easy to try to contact that many people, almost 14,000 people or businesses. So to just have 3%, it's probably still close enough, especially with a 98% confidence. So you're really making it a lot more challenging just to kind of shave off 2%. All right, that's it.